Hello YouTube, here we go again. Journey continues. One of the things I'd like to talk about today is Errata. Software developers in embedded systems seem to always forget to take a look at the Errata, and there'll be problems with the processor, issues that can cause significant development problems, and yet we constantly forget to look at the Errata. Manufacturers of processors and all kinds of parts that we use in computers, they have Errata sheets. PDF files, you can get them right off of their websites. I'm going to show you that today for the board that we're going to make use of, because it's important to know what sort of things are going to cause problems for you. Many programmers that I've worked with over the years have spent weeks trying to work out specific problems when all they had to do was to read the errata and they would have their answer. And reading erratas are pretty simple as long as you know what you're looking for, and I really highly recommend that embedded programmers become very familiar with the errata document related to the processor that they're working on. So with that, let's get started and take a look at it, okay? Okay, so this is the board that I'm proposing using in the project, or number of projects that we're going to have. You'll see right here that it is the STM32F429 ZI. I'm not going to worry about the ZI part, just going to worry about the 429. So I should be able to do a search for Errata STM32F429. Yep, we do need that F in there, and then we'll see what we find. And sure enough, the very first thing, right from STE.com, so it's right from the company. Click on that, and here's the errata. Now, we're going to use, for this first project, and I'll just use only the specific parts that we're going to deal with on the first project we're going to work on. So that is the A to D and the D to A. Makes it very simple. So we're going to go through the contents and we're going to find out where our DAC and ADC information is. Now I can see already there's some information about accuracy due to internal noise. So that's one thing we should look at. And then also we should have a section somewhere if there's any other issues. Yeah, so here at the very end there's some information on the ADC, its limitations, and on the DAC and its limitations. So this is going to be important to read this. Now this is only 42 pages long, so it's not too bad. I've seen erratas that are twice, sometimes even 3 times that size. So this is actually pretty good, and hopefully it's going to be useful. So let's take a look. So the analog to digital conversion peripheral, let's take a look at that. And remember that we're not going to use any interrupts. We're not going to use any timers or anything like that. So we're not going to be triggering off of hardware. We're simply going to read the ADC, which means we're going to have to fire it off, wait for it to complete its acquisition, and then be able to read the data from it. So from this information here, we see that there's a start bit that we'll use to kick it off. There's some registers applied to the ADC, and if you modify those registers, it stops the current conversion. So you could easily hit the start, then modify these registers if you do it in the wrong order, and then it'll stop the conversion, and you won't get information, or you'll get a partial information, which will be the incorrect numbers or incorrect values. So you want to make sure that you don't modify these registers after you've hit the start. And then, if you do modify something, you're going to have to restart it. Completely makes sense. ADCs, they don't happen instantly. they go through an acquisition process. That process can take time. And so we have to make sure that we start it, we don't touch it, so that it can make its acquisition and complete. And simply, we're just going to look for something that's going to say, hey, we're done with the conversion. And then you can read the information. Now, it might be possible that you just wait some number of microseconds and it's all done. Okay, now for the DAC, the digital to analog conversion. It looks as though there's issues to do with DMA, which we're not going to use DMA. DMA not clearing. Again, we're not using DMA. Okay, so it looks like, now it goes on to revision history of the document. You're at the end of the document. So it doesn't look like we will have any effect with relation to the DAC because we're not going to use the DMA. But there can be useful information, as this workaround here could help us understand sort of a sequence of things. I'm not going to get into that right now because I don't think it'll affect us, but we'll definitely take a look at that later if we're having problems. Okay, so this is just the first look into what we're going to need to keep our eye on. If you're working embedded processors, and if you're not constantly looking at the Errata, you're probably going to run into problems, and you're not going to be able to solve those problems. It's disheartening when you get in a situation where you work a week or longer than a week and you can't get some dumb interface to work, and then you go look in the Errata and they say, yeah, verily this won't work, but here's how you can work around it. Then you feel a little dumb. This is just a reminder to all developers, please look at the Errata. I just can't say this enough. We always make the mistake, and we always fail to look at it in times when we really should be looking at it. So keep it, print it out if you have to, and set it on your desk so you have it. Some way that you can take a look at it and it's easy to get to. Me, I take this PDF, I throw it on my desktop, and it's always available for me. Okay? Okay, now if you remember, there was this one thing left, which was this internal noise impacting the ADC accuracy. Definitely something that we should take a look at. So, in reading this, it looks like your voltage supply could have an effect on the ADC. This is probably the case with every ADC ever made. If your product is on DC power, like a battery, you're probably not going to see anything. If you're connected to AC, then there's probably some work that needs to be done in hardware to reduce any fluctuations on the voltage. They do show some workarounds, so there's a couple options to work around, which is setting a specific bit in the power, and also second option is to set a bit in the configuration. Either one of these are probably good workarounds. I'm not going to worry about it for this project because the accuracy that we're going to get is probably plenty sufficient for what it is that we're trying to accomplish. So I'm not going to worry about these at this time. But I do want to note the issue. Okay, so I've decided that I should show you saving it to the desktop. And the reason for that is because you really need to save these documents where you have both the processor number and the number that's the official documentation number from the company. So you'll see if I try to download this, they give this English and then some strange number, which is their internal documentation system. When you're trying to look at a whole bunch of erratas or a whole bunch of documents on your drive, how do you know what this is? Well, simple. Just add to the front of it, because that's what you are most interested in. And then that's the 439 as well. There. So now I have a name I can read, and I still have the remaining information about the document number if I want to communicate with ST, the company. Okay, that's it. Thank you. As always, please subscribe below and follow the links because it helps me make these videos. I appreciate it. Thank you.